Hi, welcome to All Space Considered. I'm Dr. David Reitzel, astronomical lecturer here at Griffith Observatory, and tonight's program is brought to you by Griffith Observatory, the Department of Recreation and Parks, the City of Los Angeles, and as always, we like to thank Griffith Observatory Foundation, our exclusive nonprofit partner. Tonight, with me, I have Laura May Abron, Bill Gruneberg, and Jared Head is our panel tonight, and we have a wonderful show for you tonight. First of all, this show happens on the third Thursday of every month, and you can come to Griffith Observatory and see it live in person if you like. In fact, we're coming to you from the Leonard Nimoy Event Horizon Theater at Griffith Observatory, and the theater just had some renovations thanks to our exclusive nonprofit partner, Griffith Observatory Foundation. We have a new sound system, a new projector, and there will be even more coming over the next year or two. So there's going to be some more changes that are coming to the theater. But boy, it sounds great in here. This is exciting. So you got to come up here and see it in person. Well, tonight, our show, we have our astronomy news bulletin, and we have Earth's new moon, Comet of the Century, Orcs in Space, and an Iceland volcano update from Iceland. And then we're going to catch up with Mars. Kind of literally, we're catching up with Mars. And then we have a bunch of Mars stories. We haven't talked about Mars in quite a while, so that's the main focus of tonight's show. But first of all, what is this background image that we're seeing? This is a beautiful image, and it looks a little like a question mark. This is a kind of known as the question mark image. Zoom out a little bit here. This is a James Webb Space Telescope image. And indeed, you can kind of make out a little bit of a question mark. I'll show it for the folks here in the audience. If you follow my laser pointer there, and you can come down to the bottom of the question mark. Zoom out a little bit, you can see there are lots and lots of galaxies around, and there's sort of a bigger elliptical in the foreground. That's the wider galaxy that's in there, the wider light. And we can compare it to an old Hubble image. The Hubble Space Telescope image also imaged this area. But you can see a lot more with Webb. Webb is picking up more light, more detail. Things are kind of much better. But there's some odd things going on here. Notice that those galaxies, those splotches of light above the main one, even in the Hubble image, they look alike. What are those splotches there, the little dots of light? They almost match. In fact, they match this one that's off to the lower right as well. So something strange is going on in this image. What this is a gravitational lens. That foreground elliptical galaxy has such strong gravity that it's bending the light of the background galaxy and making multiple images of it. And you can see in this one, they've been labeled A, B, C, D, E. I think there's 5 of them in there. And that E one is really kind of far away. And that's the same galaxy that's been imaged over and over again. So pretty darn cool, and believe it or not, it takes different amounts of time for those images to reach us. So if a supernova were to go off in that galaxy, it would appear first in one, and then in another, and then in another, and you can use that to track, believe it or not, the expansion of the universe. You can use that.
I don't know that.
So that's a fun one. Well, for our first astronomy bulletin tonight, Earth's new moon. Okay, no, it doesn't. It doesn't look just like our old moon. Unfortunately, that'd be pretty cool if we had a huge moon show up. In fact, it's really, really small. Earth's diameter is about almost 8,000 miles. The moon's diameter, about a quarter of that, a little over 2,000 miles. And then, of course, this 2024 PT5, is its name, is 33 feet across.
Yeah, so it's kind of interesting that we actually have, earlier when we were preparing this story, we found that there were quite a few quasi-moons, mini-moons. All these are objects that are in our vicinity, and they can often end up being captured by our orbit, but they're not always exactly on our orbit. So sometimes they can have what's called a resonant orbit, right? So it's a slightly different type of orbit. So here we've got an example of the orbit for this object, right?
This object, it's kind of going up and down in the plane of the solar system, but it passed by Earth, and kind of Earth's gravity looped it around and didn't capture it completely, but you were saying...
I think we have it for I think 50 or 60 days.
Yeah, almost 60 days.
Yeah, but we do have some, so this image, for example, is showing you a different quasi-satellite and its orbit, and that one will be around for much longer. So there are a bunch of these little objects out there. Again, they're quite different to our moon, and that's probably for the best because we don't want more tides or more interactions. I don't think that would be good for us.
Wouldn't be good. Now, this is a potentially hazardous object. It could strike Earth, but it's relatively small. 33 feet would probably be mostly disintegrated in the atmosphere. Little chunks of it might fall to the ground. Pinsky will correct us if you're out there. He's a museum guide here at Griffith Observatory that knows a lot about meteorites, and it's just fantastic. Now, there's another object that's been in our sky.
There is another object that everyone is talking about, and this happens all the time. So this is the Comet Tsuchinshan, also called Tsuchinshan-ATLAS. You might see it referred to as 62P. And so this comet could brighten or could not. This is the same thing every single time. So you'll notice this was from Harvard. They had a very cautious, I like this, it is possible that this comet could brighten. And this is kind of the game every time. You know, some of the less specialized media, they will constantly say, oh, it's the comet of the century. And in fact, you know, I found this just earlier. You can look up when searching for images of it right now. You will find last time I showed a headline in French. This one is in Spanish. Ya lo llaman el cometa del siglo. So we already are calling it, they are already calling it the comet of the century. This is a repeat. I don't know who started this comet of the century thing. I was fooled by another comet over a decade ago, Comet Ison. Some people may remember it. The problem with comets is that sometimes as they go around the sun, they will disintegrate. They will be broken apart, right?
Yeah, I remember Ison, and we were excited about it here. We were making predictions, and it fizzled.
Yeah, so I've been heartbroken too many times to not expect much, but I don't want to dampen people's optimism. Yeah. Maybe it'll be amazing. So we've got an image. This image, I found it online on Reddit, and this image is from 2 days ago. So it looks pretty good, but again, keep in mind when you see images like this in media and things like that, these are often shot from very, very dark skies. They're shot with really professional equipment, sometimes even from professional observatories. So we don't really know. It's got a predicted magnitude, so it's going to be at its closest approach to us on October 12th. And it's going to be at its closest approach to the sun, perihelion, on the 27th of September. So pretty soon. Yeah. And we'll have to, I mean, I feel like...
Yeah, we'll show you a chart where it is, but I want to point out this NGC 3292, that's a galaxy that the person was just proud to have captured. And the same thing with the IC 608, it's another deep sky object. So ignore those if you're out there watching and wondering why did they label them? Well, just the person that took this photo did. But the comet is the obvious comet-looking thing. So
yeah, what's cool is that you can almost. I was wondering if it was an anti-tail.
There is. Well, there's the ion tail.
There's the ion tail, and occasionally you have an anti-tail, which is where it passed. So Comet E3 a couple years ago had that as well. So sometimes you can even have just 3 visible tails, even though one's not really a real tail. But yeah, if you're interested in finding it, there are charts. So this one, a little complicated to figure out.
Let's zoom in where it is now. Yeah. So we'll zoom in.
So you will find it in the constellation of Virgo right now because it is close to the sun, and the sun is currently in the constellation of Virgo. So this is charting its path over the next, I believe, 2 or 3 weeks. To give you an idea, again, you don't really want to be staring at the sun, so it's best to wait until it's a little further away, until it moves a little bit away. But we hope that in October, maybe we'll have some brightening. Yeah. And you know what we were discussing earlier regarding also the difference between when we talk about magnitudes and how bright an object is going to be, you have to keep in mind a comet is a little different to a star.
Yeah. Well, it's spread out. So they're not measuring. A star is a single point. All the light's concentrated there. It's bright. So when they say it's 5th magnitude, a 5th magnitude star is pretty easy to see from a dark site. The comet won't be so easy. Binoculars can help you find it. If you have a small telescope, that can help. But really, binoculars are kind of the best thing to use. Yep. Anyway, this chart, by the way, you read it sort of from right to left. The comet right now is on the right-hand side of it, where it's labeled September there, and then you see October, and then 7, 9, 10, 11, 12 moving to the left. Those are the dates in October increasing. So that's where you'll be able to find this comet. So very cool. We're hopeful. We'll see. If it brightens up, we'll show it here at Griffith Observatory. Well, it's in the morning is the problem, so you'll have to come up on your own with a set of binoculars. But we will get images of it, and we'll show it to you here at All Space Considered.
Who says Comet of the Century here? I vote no. I don't know. What do you guys?
Yes.
Okay.
I'm an optimist.
I want to know what century.
Yeah, the things I say on this show, generally the opposite happens, so that's why I'm going to say no.
I'm going to say
it's not going to be right.
Comet of the Bicentennial.
Okay.
I'm going to keep it a little more open.
A little more open.
We'll know a lot more after perihelion, though, right?
Yeah,
we will. And one thing that's hopeful about this comet is it will be between the sun and us, so the light is what's known as sort of forward scattered rather than backward scattered. So it doesn't have to change angle much to get to us. Have you noticed when you're driving, if you have a dirty windshield, like me, I'm sure you keep it pristinely clean, right? But if you have a little dust on your windshield, it looks a lot worse if you're driving into the sun than if you're driving away from it. And that's that forward scattering. It's just a property of physics. So there's hope that this might be a pretty
Fingers
good comet.
crossed.
We'll see.
Yep.
There was another study recently by the Meerkat telescope array. This is the square kilometer array down in South Africa. This is a radio array or submillimeter array. And it's pretty neat. All these telescopes act as one. They join the light together to make measurements. And what they saw were orcs in space. I know, orcs in space. Understanding the origins of orcs. Odd radio circles. Not this kind of orc in space, although we could hope, and this is a real...
This is a real cover?
comic that you can get. You have volume 2, I guess, of Orcs in Space. Thank you, Daniel, for finding it out there. And what do they look like? Well, they look a little like this. Now, of course, you can't see radio waves with your eyes, so we had to sort of colorize the radio waves. But do you see the orc there? How about now? Maybe now? How about there? Do you finally see in the orc?
Our Photoshop department here is
working
overtime.
We're working overtime, and the Photoshop department was Dr. Reitzel. And then this was the selection of orcs I was given to choose from.
I think I prefer the astronomical orcs, honestly.
I think I do too.
I think those are the better ones.
So the astronomical orcs, this is what we think is going on. They're bigger than galaxies. These things are 10 times bigger than our Milky Way galaxy, so about 1 million light years across, so very, very big. And we think they originate somewhere inside the galaxy. How could that be happening? Well, this is what the data really look like. They're sort of these rings on the sky. And maybe there were colliding supermassive black holes. We've talked about colliding black holes. The LIGO Observatory can measure these. Supermassive ones take so long to merge. We currently don't have the ability to sense those, believe it or not. But if we did, well, we wouldn't see something like this. This is an artist rendering of what 2 colliding supermassive black holes might look like. But when they do, they would send a shock wave through the galaxy that would affect literally the magnetic field of the galaxy. And what we're seeing is a ripple in the magnetic field that causes these electrons to spiral around, giving off this radio waves. So that's one way to make this. Another way could be an intense star formation. If you have a bunch of supernovae go off, that can also send a shock wave through the galaxy and sort of compact these magnetic regions and concentrate them and make the glow. Another thing could be happening. This is a jet coming off this galaxy. We're seeing a galaxy in the middle, sort of edge on, and then a jet coming out going diagonally. Well, if that jet were pointed at us, if it were headed right to you, it might give a signal like these orcs in space. So, but the alignment has to be kind of perfect, and that jet has to have maybe shut off after a while because we're not seeing the bright source in the middle at the moment. They do see a dot in the middle, and it's a galaxy, but there's more work to be done on these. These are super interesting. They've only seen 5. So there's only 5 of these things out there so far. So more are coming. Orcs in space are a new thing in astronomy. So
emerging science.
Fun stuff. Now, Laura May, you had been to Iceland.
Right. So
do you want to just grab a remote?
Absolutely.
Yeah. So tell us about this new Icelandic volcano update.
Yeah. So if some of you follow All Space Considered, you might have seen our episode last November. I came and gave an in-depth talk about some of the recent eruptions in Iceland. I was really fortunate to visit the 3 eruptions of the Fagradalsfjall system. So this is one of the images I shot of when the eruption was just a couple days old from a helicopter staring down, just right down the barrel. It's a nice little pool of lava. So one of the projects I had there, I had some art projects. I wanted to do an in situ painting of an eruption and then sample lava onto the canvas. Do not do this at home. I had training to actually work with lava. But one of the biggest considerations when we spoke about it is that it seemed like a different system was waking up, right? So pretty near to Fagradalsfjall, there is a region called Sund-Nukagegarothin, right? Icelandic.
Say it along with us.
Right, say it with us. Repeat after us. And at the time, of course, famously, because this is how science works, you know, there were all these tremors. They had some very big earthquakes. It damaged a part of the town nearby called Grundavik. And I famously said, oh yeah, this, I don't know, man. You know, I don't think it's, I don't think it's going to go off. So naturally, you can guess what happened next, famous last words. Now it's playing. Let me see if, so let's see if is it actually playing this video? Let me
This
see.
video
Yes.
is playing.
So you can guess what happened next. We have had quite a few eruptions. So this is a video of one of these eruptions that have occurred in the past couple of months. And this is a real-time video. This is a 1-minute video showing you the start of an eruption, right? One of the coolest things about these eruptions is that people have been really excited about them, and they have placed webcams absolutely everywhere. These eruptions are the most paparazzi'd eruptions to have ever happened. And so it's brilliant because we get these amazing footage like this of this eruption starting.
Yep.
So there have been...
This sort of stuff you didn't used to see. I've been watching volcanic stuff for a long time, and seeing that steam first and then the lava, this is remarkable.
It's really amazing. And so, that fissure over the course of an hour is going to grow. So we'll have this long chain of eruption, several kilometers in fact. And so we just had, when we started planning this episode, we had the 6th eruption since December last year. So different to the previous system, which was erupting roughly once a year. This time it's been almost every single month. So we started planning this episode and I was very excited there was a new eruption, and it's already over, right? It lasted, I think, 14 to 20 days. And so all of these eruptions are part of really one system that is on what we call the Reykjanes Peninsula. It's on this kind of bottom tier of Iceland, and it is a little unclear whether it's a bunch of separate systems or one system. It's called an echelon volcano or echelon system, and that's something that's being investigated right now. One of the foremost volcanologists in Iceland, he was talking recently about how they think it's one system. And so all these things are kind of working together, and we have to understand how. So this is an image of this very last eruption that really just ended a couple of days ago. Pretty remarkable, the amount of lava it put out, 7 kilometers long fissure, maybe 3 miles, something like that. And yeah, lasted 14 days, 3rd longest, largest so far. Now what's particularly remarkable about these eruptions is that there have been many efforts to divert them. And there's quite a lot of history of this. So this is a fresco from Italy that represents Mount Etna. Now, many people know Mount Etna. It's one of the most famous volcanoes because it erupts so often.
I think it's erupting now.
And it's erupting now, that's right. And so, rather amusingly, people from a town there called Catania tried to divert the flow to another town called Paterno. You can guess. These people were not very happy about this. And so they actually stifled their efforts. There was a bit of a fight. But there have been, over time, many, many efforts. There were aerial bombings that have been tried. They've tried cooling off lava. And there's a really cool cultural aspect to this. I spoke to an Italian friend of mine earlier, Francesca, and we were talking about how, in Iceland, for example, they like to fight their volcanoes, right? They're like, no, we get on with things. In Italy, they have these kind of rifts as to where are we going to send it, and we've got rivalries between places. And then in Hawaii, it's a little bit different because the volcanoes have a more sacred nature. There's a little more respect for, this sacred aspect of nature. So, but I do want to tell you, so this is an image from, I think it was the 2nd eruption that happened of this system. So unfortunately, you can see that a little part of it did reach the town of Grindavik. It burnt down just a couple of homes, very unfortunate, but the good news is that they were able to do something quite remarkable that they're still doing now, by the way. They are building all of these barriers, or berms as they're calling them, to protect the geothermal station and the Blue Lagoon, famous attraction there. And it's pretty much the most successful attempt that's ever made to divert a lava flow. So it's remarkable to see this, remarkable amount of people working on this. There are videos online where you see them pull away these bulldozers and the lava is just right there. And I can tell you from standing next to lava, it is very, very hot.
Yeah.
So a remarkable achievement and hopeful for the future of Iceland. And this is a nice segue into our main topic for tonight, which is Mars, because Iceland has actually been used as a Mars analog. And so very recently there was a conference there hosted by the Icelandic space agency that is called ISA, or ISA, and they use parts of Iceland as an analog to Mars. This has been done in the past. They have used Iceland as training grounds for astronauts, believe it or not, before they were headed to the moon. There are a lot of very interesting landscapes in Iceland, and so now they're doing something similar. I believe this section on this image is a little similar to Jezero Crater, and so they are collecting specific types of rocks to analyze them, to train the scientists, and also potentially for when we at some point get the Mars sample return to see kind of how they can get things out of the little containers. So there's a lot of work happening now, and there was just this workshop in Iceland. So Iceland to Mars.
Yeah. I'd like to go to that workshop. I want to go to Iceland. But
Right.
Your talk of the berms reminded me, of course, of this movie that took place in LA, was supposed to have taken place. And they used the K-rails. You could see the rails they put in between the highways to block the lava. Those are not strong enough. It wouldn't actually work. But in principle, it's the same. So the movie's completely realistic.
Didn't have enough engineers consulting on the film, I think.
Well,
but,
that's a problem with a lot of films. If they just consulted
That's right.
us.
If it works for Caltrans, it can work for nature.
Yeah, you can contact me here at Griffith Observatory.
Movie magic.
Need some help. Anyway, moving on. I mentioned that we are catching up with Mars, and literally we are catching up with Mars. Mars in January will be what's known as at opposition. Right now it's ahead of us, and Earth orbits faster than Mars does, so we're catching up to it, and soon it will be opposite in the sky from the sun. So it'll be closest to Earth for this near period of time. In fact, if you look at it through a telescope, you can see here dates: August, October, November, December, January. It changes size a lot. We get a lot closer to Mars over this period of time, and then it will shrink down. So it'll be about 14.5 arc seconds. What is that in size? Well, that's pretty small. That's really, really small still. Mars is not going to be that big this time. And it's because this is not a great opposition. In this diagram, there's a few Marses in there, so let's go through it slowly. You can see December 2022 opposition. Look at the distance between the blue line and where Mars is, and how that changes. For our current one, the January one, it's a long ways away, but it's not as far away as it can be. That aphelic opposition is the maximum distance Mars can be away from us for an opposition, and then that perihelic opposition, Mars is actually quite close to us. And that last happened in about 2018, and you can see how much bigger Mars is when it's at that perihelic opposition. So 24.3 arc seconds in size, that's an extra 10 arc seconds. That's like almost double in size, not quite for what we have, but close to it. And then in 2035, get ready, set your calendar, set your alarms.
Yeah, baby.
Exciting.
It's got to be a big one, 24.6 arc seconds. Mars will be fantastic to see through our telescopes here at Griffith Observatory. So get ready for that. You're going to want to be ready.
We all have to live a long time in astronomy because things are far away in time.
Yeah.
They really, really are. Well, I'm going to move on to our next little story here. Sorry, we have something going on in our audience that's amusing us all. So at home, watching us on YouTube, you just need to come to Griffith Observatory if you want to get the full experience. So this is the Perseverance rover, 2020 rover as it was called. It was sent to Mars in 2020, and it's been exploring there and looking for, well, really signs of life, sort of things that might give a hint that there was life on Mars once, and taking samples. So this is the full path that it's taken since it landed in the lower right, sort of this meandering path as the scientists see interesting things. Anywhere you see one of those red little balloons, it took a core sample. It drilled in. Now they had mentioned this was something like its 24th or 25th. It says 25 sample, but a couple of them, 2-3 of them didn't work. So it's its 25th attempt, but I think the 22nd successful sample. So you'll see some numbers a little different. But what did it sample there? What was going on? So let's take a look here. Zooming in, that most recent sample, it's sort of the top center there. It's moved on away from it. Perseverance is driven off. But it was looking at this rock. And it's an interesting rock that had leopard spots on it. And no, not
Adorable.
Adorable, but not leopard spots like those, but kind of similar. We'll zoom in on them here, and you can see this is a section of that rock, and there's two sort of diagonal white areas. That's water that came in and left deposits there. But in that reddish material, that's made of, well, hematite and iron compounds. And inside of there are these little spots. Just labeled them as leopard spot there. The other thing labeled is olivine. Olivine gets made in volcanic eruptions like that. So how that got there, we're not sure. We think maybe it was washed downstream and then washed down into here, and then that calcification that happened, that olivine was cemented in place. So this rock had flowing water. It had this weird signs of these leopard spots. We see those leopard spots in places on Earth where there is life, where there's bacterial life. Now, the bacterial life, I don't believe, I did a lot of research on this, and some people are claiming the bacterial life is causing the leopard spots. But if you dig a little deeper in the NASA pages, it's talking about, it seems to be a naturally occurring process where that iron is being converted and it's leaving behind some phosphates and other materials, but it gives off energy when that happens. And those microbes like the energy. They can use that as an energy source to live. So I'm a little confused by it. I want to dig a little deeper. We're going to do a story on astrobiology coming up in the next several months, so keep an eye out on our webpage for that. But this is the strongest sign that life could possibly have existed on Mars that we've seen yet. These leopard spots, people seem pretty darn excited about them. Now, what are the steps? This is the cold scale, and of course I don't remember what the COLD is for, but this is the steps that astrobiologists use to say, have we really found life? So first, detect a possible signal of some sort. Well, that's kind of what this is. Rule out contamination. Well, they need to do that. They need to go and say, could this have happened in a different environment? Maybe this was next to a hot spring and it was at, 6,000 degrees Fahrenheit and it was super hot. Who knows? I mean, temperatures can rule out biology, and if you can find another way to make this stuff, whatever. And that's step 3. Make sure biology is possible. How this thing actually formed, we need to figure out and say, could life have been there? Then we need to rule out non-biology. Could there be ways to make it that it wasn't little microbes? Then, additional independent signals. Can we find more leopard spots on other rocks? Let's go looking and find more. And then also rule out other hypotheses. People will try and shoot your idea down, say, no, it's not life. And then lastly, independent confirmation. It'd be great if somebody else sent a rover and drilled into it. Come on, Europe, send it in there and go find us some leopard spots. So there's a long way to go before NASA would feel comfortable in saying, we have seen life. But this rock's exciting. They took a sample of it. They haven't left it behind yet. They'll drop them behind on the surface at safe places that the sample return mission, fingers crossed, we'll hopefully talk about that a little later, we'll be able to go pick this up. So for right now, all we have is Perseverance going, what? Maybe there's something there.
What kind of rock is this? I don't know.
I don't know. They're the weirdest rock I've seen yet. But it's very strange, very exciting, and I'm thrilled by it. This is what Perseverance was sent to Mars to do. Now, unfortunately, you need a lab that's bigger than the rover to be able to analyze it and see whether there are actually fossilized microbes there or not. But go pick up the sample, bring it back to Earth, and we can do that. So
we really need that mission. Some of you may know, or the Mars sample return has been a little bit sidetracked.
Yeah, we'll talk about that in a little bit. It's coming up in Jared's section. We're going to close the show with an update about some Mars missions. Yeah. But first, there was a simulated Mars mission here on Earth. Some folks got together and they were in a habitat, right, Bill?
They absolutely were.
You can grab a remote there.
Okay. Which way am I going here?
So use these arrows.
Oh, all right. To go forward.
There we go.
Yeah, I had to look up how you pronounce this. It's the CHAPEA mission, the Crew Health and Performance Exploration Analog. It's an analog, meaning as close as they can come to what it might be like to live on the surface of Mars. We'll go into a little later all the things that they can't emulate, but this is what they did. They took these 4 people. The 2 of them were women and 2 men, and they closed them up. They were volunteers, of course. Closed them up into...
You'll get in there and you'll enjoy it.
Well, there is an analog for prison also, which is the same thing, but you don't have a choice.
Is that what space is? Is space prison?
Well, once you're there, sort of, yeah.
Yeah, well, for the astronauts that are stuck on the space station right now.
They are a little
that's
Starliner.
They're supposed to be there for what, 48 hours or something?
Something.
Months,
And the Starliner came back without them, anyway.
We don't use the term prison. It's not,
No.
That's a mess.
Well, too late for that now.
That's
So why this is important, and there are all sorts of reasons, but basically they want to know if 4 people can live and function and survive in terms of health and psychology and every other way and get along over a 7-month period, which is, I'm sorry, a year period.
Yeah.
It's I was thinking about the trip to Mars, but we'll get into that in a minute. So this mission lasted a little over a year. It was a year and 2 weeks roughly. And they seem to do fine. You can see they came out on July 6th in 2024. And you might even have seen this in regular news broadcasts because they were covering it pretty widely. Okay, so here are the 4. And they this is after the fact. They've come out of the habitat and they seem to be very happy. That's that's not science, but it's a data point of some sort. I don't know. Here they are coming out of the habitat. They look very happy. And I want to show you a quick, I don't know how well you can see. Yeah, you can actually read all of that. So there are 4 sort of dorm-like rooms for the 4 crew members.
Yeah, when they were picking this apartment, this is what they saw on Zillow, right?
That's right.
I want to know if their rooms were assigned, or did they have to actually, pick straws or flip a coin?
I mean, you'll see the rooms are really similar, but
It's better than the base they looked for on Craigslist.
Yeah.
well, that's true. That's true. So there's all kinds of areas in here which you can read, and lots of bathrooms and showers, and a fitness center, and a crop area. Now, food, they had to bring as much as they could realistically take on a crewed mission to Mars, and then grow what they needed beyond that. And we'll see some of that in just a minute. So, what do the rooms look like? By the way, I want to point out this is a 1,700 square foot habitat, and it was 3D printed, basically, by machines, and NASA believes that this is something they could realistically build on the surface of Mars for actual astronauts who go there. Here are a couple of the dorm rooms. They look like. I think they're probably comfortable. They look fine to me. But that's where, if you were in a mission like this is where you would sleep. Here are some other work areas. You've got a work area on the left, entertainment in the back, kitchen on the right. I think it looks kind of cool. Of course, there's going to be no windows in this place. That's sort of, I don't know if there's a psychological effect there, but absolutely no windows. And this is something they modeled as well. This is a simulation of what they might find in the Martian environment with the red sand and the rocks and all of that. And here's somebody doing some work. Now, it seems silly to go out and collect samples in this place, but they will be doing that. They wanted to simulate all of that. So here's what they simulated. They simulated that. You have to. They assigned that. You had to exercise. You had to. There were responsibilities and duties about keeping up the habitat. There was a lot to do there, and they had stressors. They had these things that were planned, like a piece of equipment would fail, and they had to deal with it. Stuff like that. Also, and here's a nice one of the crew members having a great exercise routine, and here's some of the tomatoes being grown. One other thing that they did do is you could phone home. You can phone home from Mars. I mean, it's electromagnetic, the radio waves, and they travel from Mars to Earth. The problem is, at our closest, that opposition that's coming up, the very closest is about 5 light minutes away. So you call up your friend and say, "Hey Joe, how's it going?" It takes 5 minutes to get to Joe. He hears that. He says, "Not bad, how are you?" And it comes back to you. And that's a 10-minute round trip. It gets up to as much as a 44-minute round trip per communication when the 2 orbits take us as far away from each other as possible. But I think this agriculture looks really, really good. And one of the big things was food management. That's one of the things that they wanted to study in this. NASA wanted to get data on, for future missions.
Yeah. Well, you don't want to be stuck having to grow potatoes.
No, I guess not. Yeah. I'm not sure why, but
it's a Martian reference from the movie The Martian.
Oh, right. Yes,
anyway,
I remember.
We won't talk about what he had to go through.
Were there any results of the psychological assessment?
Not yet, not that I've heard of, and I haven't really. They talked a little bit. They all had a paragraph of information coming from each of them.
They all immediately exited and unfriended each other on social media. That's my guess.
That would be a good data point too. But they, So, all right. Why can't I think about?
Did they make a delay on their calls?
They did.
They
simulated the delay in time calling home. basically, talking to.
Yeah.
Who calls anymore? People text, right?
Well,
no one
text-
calls
You got
anymore.
a 10-minute wait for your flight.
It's
Okay, well,
texting.
people wait 10
Sure.
minutes. That's
Yeah,
normal.
that's true.
Would you
That's
notice
true.
it?
For texts, that's
Yeah.
normal to,
Yeah.
I
It'll
wait
work out.
days sometimes for a
So
reply.
now, do we have footage of them emerging?
So being left on read is actually a good thing if you're
Right?
on Mars.
It's
So-
maybe the person I'm texting is actually on Mars.
Yes, I don't know. So,
I'm gonna.
a lot of my friends are on Mars for some reason.
We're going to use that. Now, is there footage of them exiting? I think there is.
There is. Isn't this the? Wait a minute.
There it
yeah,
goes.
there we
There
go.
they
Oh,
are.
you changed it. All right. Yeah, here they are coming out after a year and 2 weeks with one another.
I don't know why it's lumpy.
Not much moving in this movie.
No. Yeah, we have some issues with some of our
Yeah.
equipment sometimes.
That's this equipment, though, not the.
Yeah, it's the
redo of
video's
the-
fine. It's this equipment.
It's our setup. It's our setup. So
Too
Yeah,
powerful.
it only works. It only works for Ella, and I don't know why.
Yeah,
but
well,
it's true.
still.
Well, here they are, happy as can be, holding their mission medals, their little coins
Yeah.
they got.
By the way, I want to
challenge
point
program.
out there's a CHAPEA 2 and a CHAPEA 3 planned. CHAPEA 2, they've actually closed off they're not accepting any more applications, but in CHAPEA 3, you still can apply.
Would anybody here apply? Raise your
A
hand if
little
you
bit
would
over
go
a
in this
year,
for a year.
And, all right.
Yeah, one
there
person.
we go.
One person.
That's
What
cool.
food would you bring with you? Blueberries.
Oh,
Okay.
all right.
Very nice.
they pay pretty well, from what I remember. There was a study that was done by I think European Space Agency where they wanted people on beds, basically to not get up for a certain amount of time, and it was
Yeah.
to do with the flight and things like that.
Yeah.
Mimicking. Yeah.
I would like to point out that on Mars there's significantly more radiation than there is here. It's kind of like space. Also, there's the trip to get to Mars. NASA predicts it probably was going to, based on current technology, take as much as 8 months. They might improve that, I guess. So it's 16 months of round trip flight plus whatever time you spend on the planet of radiation. And in this habitat, of course, you're getting full Earth gravity. Gravity on the surface of Mars is about 38%, which is great if you want to weigh yourself and feel like you lost a lot of weight. But
You could do
but
that
it's-
in our Gunther Depths of Space.
That's right. That's true. Go weigh yourself on Mars. Yeah. But it's not good for bone density. It's not good for muscle mass. It's not good for your health in general to do that for a very long time. So this, experiment, this analog didn't, cover that obviously. But there's a lot of interesting. Oh, that's me, I think.
Yeah.
Somebody's
Watching you and has decided to call you.
This is
We're
why-
not
Is it
we're not
Jimmy?
on we're not doing the Mars experiment here, and so
This is
yeah,
that's right.
we get calls.
We'll get back and
I'll get back to them in
22 minutes.
I'll get back. Oh yeah.
So now I want to say the very last thing is, and especially if you go, one of the things you come home with is a mission patch from a NASA mission with your name on it, and I think that is just awesome. I almost would, give up a year of my life just to get that.
That would be very cool.
Almost like-
That would be
Pretty
something to talk
prestigious.
about. Now these people, the other thing they did not suffer is Mars's weather. And this was the latest weather in Gale Crater. Curiosity is there. We have a rover there, and it's taking weather. And
Yeah, if you've ever been curious about your weather forecast, you can actually look up the weather on Mars.
bad.
So here we've got a little sample of some recent days. So Sol means the specific day. We use slightly different terminology for Mars. And you can see the highs, the lows. So we do have a little bit more of a temperature swing than we do on Earth, just a bit. Feels like LA weather the past couple weeks. But many people may have seen this scene from the Martian that we referenced earlier. They have this massive sandstorm. And sandstorms are a real thing on Mars, but they don't work quite like this, right? So suspension of disbelief, we have to give it to Andy Weir, who wrote this phenomenal book. That is the one thing that is a little inaccurate. You can't really have these kind of events on Mars.
it wouldn't knock over a rocket.
Yes.
Yeah.
But you do, and it certainly, the atmosphere on Mars, the important component is to know that it's about 100 times thinner than Earth, right? So when we are looking at that atmosphere, when we're looking at wind and things like that, it doesn't behave quite like Earth because it just doesn't have enough molecules to push around, right? Also doesn't really have water, has a lot of dust. And so we're seeing in this image this incredible dust storm, sandstorm that can envelop really the entire planet. So this is one from 2001.
If memory serves, the last Mars opposition, there was a planet-wide dust
That's
storm,
right.
and
Yeah.
everybody was
Yeah.
looking at a big ball of Mars
Yeah.
looking
Yeah,
like that.
a little disappointing for observations when it looks kind of uniform. And these tend to occur roughly every 5.5 Earth years, so that's about 3 years on Mars. And they can grow, again, to this enormous capacity, but there's a lot of also local and regional storms. So we see, for example, this is an artist impression of what it would look like from the view of our equipment. And this is really important for us because dust. So keep in mind, on Earth, we also have dust, but we also have a lot of water to kind of contain it, to play around with it. That's not the case on Mars. So we have relatively different effects. And you may know that on the Moon, for example, we have a lot of issues with dust. That is a humongous issue with sending people to the Moon. Lunar dust, very abrasive, very toxic. It's actually, I think, you may know this, Jared, it's actually, I think, gone through some of the materials of some of the astronauts.
Yes. Essentially, the lunar dust does not go through things like wind or water erosion.
No erosion.
The erosion is essentially impact events on the surface. So you literally get shards is what they're turned into. So it has literally gone through spacesuits and eaten joints in them. And in addition to that, every Apollo astronaut from a lunar mission that landed on the surface did report essentially an allergic reaction to the regolith, even when opening up the lunar module after landing back into the command module. So,
we're allergic to the Moon.
Yes.
But we still want to go there. So on Mars...
Smells like gunpowder, though.
Oh, that's right.
Yeah.
Because someone made a perfume, I think, that was like lunar dust.
Oh, de
someone will have to let us know if they bought it. So on Mars, we have a similar issue for different reasons. There's a lot of electrostatic in this dust, and that's bad for our equipment, right? So in fact, one of the rovers, rest in peace, little rover, was killed by a dust storm. I think it was Opportunity.
Yes.
Yeah, I think it was Opportunity. So this is another image, beautiful image. It seems dreamlike. It looks like it's from the film Dune. But this is a real image of a sandstorm going across the surface of Mars. Now, something fun that people don't always know about Mars and all of these storms, some of you may have seen this film that came out this year, Twisters, the follow-up to the famous Twister film. Well, we have some on Mars. Okay, they're a little different to tornadoes on Earth, but we will have these amazing little dust devils all over the surface of Mars. Believe it or not, there are up to about 140 million of them every single day on Mars, right?
And this is a real image, by the way, taken from orbit.
Yep, so some of them can be as high as about 1 kilometer. They're, I think, about 13 on average, 13 feet wide or 30 feet wide. So they're, again, because we've got less stuff to push around, the atmosphere's thinner, we don't have that same wind capacity. Some of them, in fact, don't even lift anything, any dust. But they are still around. They can still, we want to know more about them because we're going to send equipment there, and they're all over the planet. So this is a little footage, this is some footage of one of those little dust devils. It's pretty amazing just to see. There's actually quite a lot of videos out there. If you're a fan of those, you can look up videos of different dust devils. And again, similar processes to how we form storms on Earth. The sunshine is heating the surface and we've got this hot air rising. We just don't really have this component of humidity. So in fact, if you ever go to Death Valley is sort of a good analog. It's like a warm Mars. And if you ever go to Death Valley, I've driven there many times and you see a lot of these dust devils. Just outside your window, you'll see 3 or 4. So it's a pretty good comparison. And here's a simulation that shows us the decrease in power during a sandstorm from one of the rover's perspective. So really, not something you can understand why one of those rovers, obviously, that was solar powered, unfortunately, that ended it. So these are all things that we need to work on before going to Mars is other power sources.
Yep. Well, we've been doing that. For example, the Curiosity rover here and our Perseverance rover, they have nuclear sources on them. So the decay generates heat. That heat generates electricity, essentially. So, a nuclear-powered rover, we don't have to worry about Curiosity failing that way. In fact, Curiosity made an interesting discovery. Curiosity has been exploring, going up Mount Sharp, cruising up there, and it rolled over a rock. And that's kind of common. It's done that. It really damaged its wheels doing that, so they kind of try and avoid ones they think are sharp. But this one didn't look like it would hurt it. It rolled right over, but it broke open, revealing these green, looks almost like gemstones, sort of. They're not. That's elemental sulfur. We've never seen elemental sulfur on Mars before. Really, really strange. So, of course, they sampled it. There's the drill holes there. And they're very interested in that pure sulfur crystals that were found there. So very, very odd. Now, does anybody remember what pure sulfur might have been used for by Captain Kirk back in the day?
Yeah.
Yeah, he was
right.
fighting the Gorn.
Pretty cool.
There he goes.
Got him.
Yeah, this was the clip our team got. But you can see there in the image, on the right-hand side under his right arm, there's that yellow powder. And indeed, he had mixed the sulfur with the saltpeter and whatever else. And I forget the recipe. I don't want to give it to kids out there. It's not safe. It's not quite that easy to make, honestly. But we were amused. We're in the Leonard Nimoy Event Horizon Theater, of course, and Leonard played Mr. Spock on the series. So it's proper we reference it. But elemental sulfur, very interesting. What else are we going to find? It's an important element, and it's right there on Mars, just hanging out in a rock. How did that rock get there? How did it happen? Well, they're going to have to study that and figure it out. Meanwhile, Curiosity's continuing on up the way, up Mount Sharp, exploring, continuing to look for environments that might have been habitable for life. So we're exploring Mars. Very fun stuff. Now,
Can I just say, as I recall, Apollo 11, Armstrong and Aldrin, when they got back into the capsule after being outside, said sulfur was one of the things they smelled when they took off their equipment.
He's sort of a gunpowdery, sulfury smell, yeah, that sort of gunpowder lunar smell. Astronauts in orbit up in space will come back in and say they smell sort of an ozone-y smell. And I think it might be the atomic oxygen interacting with the Teflon on their suits, creating actually O2 and O3 can be created when they come back in, gets released.
Rotten eggs, that's what they said.
Rotten eggs, yeah. The sulfur smell.
All of Iceland smells like rotten eggs, I can tell you that.
Now Mars, believe it or not, has a magnetic field much like Earth does. In fact, Earth's magnetic field right now has been interacting with those solar winds, generating the auroras, and creating those beautiful displays. On Mars, they actually mapped out the magnetic field a little bit, looking at Martian aurorae, but they don't happen at the poles normally. It's kind of a confused subject. But Laura May, you found an article talking about using Martian meteorites.
Yeah.
How does this work?
So, there is a good connection between, unsuspectingly, we wouldn't think necessarily there's a connection between meteorites and magnetic fields. So, as Dr. Reitzel was saying, we've got this beautiful illustration that shows our beautiful magnetic field on Earth protecting us and doing its most right now. We've got a lot of solar activity. Not quite, you can see even just from that little illustration, not quite the same on Mars. Mars has a very weak magnetic field. There's a couple of theories as to why that is. There was a mission a couple years ago that had some really amazing results called the MAVEN mission, Maven or Maven, that showed, let's see if we've got, I don't know if we're going to get a video playing for this. Suspense.
Push one more time. Oh,
nope.
No.
All right. Well, so it was essentially, it was able to detect what happened to or how much of the atmosphere Mars was losing over time, right? And so it loses, believe it or not, and I'm going to use metric again, I'm sorry, it loses about 100 grams per day of material from its atmosphere. And that becomes actually more during big solar events. So this is a topic of investigation. We want to know all of these connections between the atmosphere, between the magnetic fields and things like that. Are we going to try and get this?
Yeah.
Nah? All right. You can look up certainly the MAVEN videos online, but one of the ways we can get a lot of information is through meteorites. So this is just to show you a rough illustration of a meteorite, space rock. So rocks from Mars are very interesting to us because they reveal a lot of things about that planet's formation, that planet's evolution. And believe it or not, there is a memory in the rock. It can sound a little pseudoscience-y, but I promise it's true. There is a memory of the magnetic field that was on Mars from when, for example, these little meteorites, these little rocks were formed, right? And unfortunately, when people hunt for meteorites, they often use these very, very powerful magnets, and that instantaneously almost destroys magnetic information inside of these meteorites. Now, it doesn't, physically change things, but again, all these minerals have magnetic properties. You mentioned, in fact, earlier, hematite and iron and things like that. And so this is very, very important. A couple studies came out. There's a team in France, in Aix-en-Provence, called Cerej. They have sampled thousands of rocks. They work predominantly on this. And this is a very famous meteorite. It's called NWA 7034. Also called a Black Beauty. It is a wonderful Martian meteorite, and we do have a little slab up in Griffith Observatory from Mars that you can look at. And so all of these meteorites are very, very important, and so there have been a couple of studies out urging people not to use these magnets anymore. So if you were thinking about picking up one of these prospecting sticks, I don't know if people are using these on beaches. This one seems to be specifically for meteorites. Don't do it anymore, right?
I like that it can pick up 25 pounds, though.
It's amazing. Yeah, I kind of want to buy it for just other uses around the home. But that same team, so Suraj actually had this amazing device. Earlier you mentioned a theremin that it can kind of almost have...
It looks like a theremin circuit, sort of. There's a coupled oscillator there, and putting the rock near it will alter sort of the capacitance or the coil and change how it's resonating. So I think that's what they're using.
It's a fairly simple. We can always link the paper if people want to look at it. It's called a MET, a meteorite meter, and it basically is able to figure out kind of the magnetic properties. And it's an amazing tool. I hope it gets commercialized. I don't really know where they're on. I wish we had one.
Well, we're going to try and get one.
Yeah, we should get one to identify meteorites. Very useful, amazing tool and concept that they've put together. And in fact, we have some meteorite news at the observatory.
Yeah, we do. We have a relatively brand new meteorite for us. Now, this is billions of years old, and it fell in Los Angeles a long time ago. But we have a brand new 350-pound iron meteorite, the first meteorite ever recovered within the city of LA. This was found in El Segundo. So we have the one meteorite that is ever known to have been found in Los Angeles, the city of LA, right here at Griffith Observatory. And it is an iron meteorite, and it is beautiful. It is a beautiful sample. By the way, several other meteorites have fallen within LA County. They were stony, they were more rock-like. So this is the first iron meteorite in, I think, LA County even that's been found. So come to Griffith Observatory, take a look at our beautiful new meteorite. It is super, super exciting.
And it sat in a yard for 60 years.
For like 60 years, it was
Yeah,
hanging out.
incredible.
The people didn't know it was a meteorite, and a friend of theirs came by and went, I think this is a meteorite, and they sent samples out or had it sampled, and sure enough it is, and now it is on loan here to Griffith Observatory, and we are thrilled to show it off. By the way, that's a magnifier, that little ring you're seeing in front of it, so you can actually see the crystals that form within these iron meteorites. That only happens in space. Iron here on Earth will cool down too quickly to form the crystals, so that's one way to know that it is an actual space rock. So very fun.
Amazing.
Now, another mission that was on Mars for quite a while, no longer functioning, was called InSight. And there's a new result came from InSight. It dropped a little seismometer. It was measuring Mars quakes, tried to drill down into the Mars soil to measure conductivity. That part kind of failed. We learned about the Martian soil, so even failures, you learn things. But it was measuring earthquakes. And in those earthquakes, you can sort of sample the inside of Mars by seeing how those quake waves respond. For example, earthquakes don't like to go through liquid. It's how on Earth we discovered the liquid core of the Earth. The earthquake waves go down there, they will refract and bend off of some structures, but liquid, a certain kind, don't like to go through it. So Mars has these little Mars quakes, and the InSight lander was measuring them. And they did map out the center of Mars a little bit. But this recent discovery is there seems to be water-saturated ground underneath InSight. Now, it's quite a ways down, so it's not right under the surface, but there's this dry, fractured upper crust, and then down inside, this layer of literally liquid water, they believe. So if Mars was once alive, maybe those little microbes have retreated deep down into Mars where this water is. If there's sort of a hydrothermal vent, if there's any volcanic activity or even leftover warmth, that might be enough to keep them alive. So we're not sure. Could be. Here on Earth, of course, this is very common. Water will seep down into the soil, it'll go into aquifers, it'll be kept in sand and gravel aquifers that are very deep. Now, on Mars, we think it's more like that fractured rock aquifer at the very bottom. They think it's more like that. So it's not going to be an easily accessible sand aquifer we can drill down into and see it. Now, this isn't the first time we've seen hints that there's water on Mars. This was Mars Odyssey, a spacecraft that was sent there, and it was able to measure neutrons coming up off of Mars. Well, where there's frozen water, you get these extra neutrons coming off of it. It's a sign that there's hydrogen there and whatnot. But anyway, the blue is an indication that there's probably ice under the surface there. And sure enough, we went and saw impacts, little impact craters like this one, and you see that white material around that impact? That's water ice. It goes away within a few days. They would photograph this later and it would be gone. So we're definitely seeing that there's water ice up high, and down below where it's warmer, there's liquid water on Mars. So back in the day, Mars might have had an ocean like this. This is becoming more and more plausible. Some of it was lost to space along with the atmosphere, as we were seeing by the MAVEN mission, but other parts of it may have gone and retreated down into the planet. Now, does this mean people can go there and drill down and get to it? Not quite that easily, but it does mean that there's maybe we get a long enough drill, we could go down there and see if there's life down below on Mars. Maybe. Long way to go for that, though. Well, there are some missions. Yeah, Bill?
Yeah, I have a question. I mean, if that one meteorite impact was able to spread a little bit of ice, that would imply to me that it isn't necessarily that deep. You know what I mean?
Well, that's the frozen stuff. The liquid water is deep, but the frozen water isn't very deep at all.
Oh, okay.
Yeah,
I
it's
thought
interesting.
If it was water for use, then they'd be able to take the ice.
Well, they might be able to.
Yeah, okay.
Yeah, they might be able to take that frozen and the frozen up top we could use. We could separate the hydrogen and oxygen, make rocket fuel with it, we could drink the water, we could grow plants with it, all of that. But that liquid water way deep under, kilometers and kilometers down, and I'm forgetting the exact number. Does anybody remember it? I want to say like 20 kilometers
Yeah,
down.
I think it was 20 to 30
It's not
Very
reachable easily, so it's 15, 20 miles down.
Just about it. I would say just about the depth that most oil, like some of the deepest oil drills and wells are at. So very
impossible.
difficult here on Earth to do that, let alone on another planet.
It's really hard to do on like a comet or an asteroid. Wasn't that another movie?
Yeah, deep Armageddon.
Armageddon.
Which is an art film, as far as I'm concerned. It's beautiful. I love it.
And we'd like to do this on Europa, obviously,
Yes.
but very hard to do through all that ice.
Let me explain why we want to do it on Europa briefly. That is a moon of Jupiter that has a liquid ocean underneath and a crust of ice. And underneath that crust of ice, that water could have life. We're not sure. And in fact, our guest in November will be Dr. Bob Papalardo. He is a mission scientist on the Europa Clipper mission that is going to Jupiter and will be studying Europa. So it kind of brings it all home. But first, we're going to close out tonight with a little bit of talk about some of the upcoming missions to Mars. This is the current missions that are there. You can see Mars Express, Mars Reconnaissance Orbiter, MAVEN's there. And some of these are no longer operating, but this is the past. Here is the future. And Jared, why don't you tell us a little bit about these future missions?
Yeah, we've got a very exciting set of missions that are coming up. The one that probably gathers everybody's attention the most is, of course, NASA's Mars Sample Return mission. This is going to be the most complex mission anyone has ever attempted. We are literally going to be launching a lander to the surface of another planet, landing not just a lander, but a rover and a rocket on the surface of Mars, having that rover go out and retrieve the samples that Perseverance is dropping onto the surface of Mars for us, bringing it back, putting it on the rocket, launching the rocket into orbit around Mars with the samples on board, having a spacecraft in orbit around Mars for the samples to rendezvous with, putting those samples from the rocket into the spacecraft that's there. So it's not just rendezvous, you have to transfer them from the rocket to the spacecraft, and then having that spacecraft break orbit from Mars, come back to Earth, and then bring those samples back to here on Earth.
You make it sound so easy.
How hard could it be? It's a piece of cake, right? Sounds so easy, right? And let's not forget, of course, the part that you have to have a laboratory here on Earth that can actually handle these kinds of samples, keep them clean, and you also have to have a method by which to, wherever your samples land at, to bring them from where they've landed to that laboratory to keep them clean as well. It is going to be one of the most ambitious undertakings in the history of humanity, period. Not just in science, but in anything that we have ever done. So it's going to be expensive. Like if you thought J-Dub was expensive, have I got news for you? It's almost like The Price is Right. How many zeros should go behind these ones?
But there's a rock with leopard spots waiting for us.
I know, but it's very hard to get the people who put the money into the places to do so. But we're working on it. NASA is actually looking at possibly soliciting commercial entities to partner up with them to help with this, which is not something, it is not unprecedented in NASA's history. We had the Commercial Orbital Transport Services, which is the COTS program, which is where we got Dragon and Cygnus out of, so SpaceX's Dragon and Northrop Grumman's Cygnus cargo vehicles. And then we also had CCDev, the Commercial Crew Development, which is where we got SpaceX's Crew Dragon and Boeing's Starliner out of as well. We won't talk about Starliner, that's for sure. So that's one of them that we have. We also have JAXA's Martian Moons Exploration mission, which I think is super, super cool. This is going to go into orbit around Mars. It's going to fly by Deimos a couple times on its way to actually going sort of into a weird orbit around Phobos, because in case you wanted to know, if you wanted to orbit around Phobos, you actually only have to go at about 30 miles an hour to do that. Wow. So I was just thinking of driving on my way up here with some of my off-roading exploits I've done in my Jeep, having gone well above 30 in some places. If you hit a bump just right on Phobos, I could have flown into orbit, like escape velocity away from it.
We should point out those are moons. Phobos.
Yes, the moon's Jupiter. Mars. With that there. Phobos, the largest moon, where it's about 25 by 20 by 20 kilometers there. And it's actually going to go down to the surface of Phobos and sample it and then return those samples to here on Earth. And I think that'd be great to compare that with asteroid samples that we have received from both JAXA and NASA missions that have been here. And a little joke for us, maybe we could sample the monolith of Phobos.
Maybe.
Yeah, with that there. So,
are we likely to get those Phobos samples before the Mars ones?
Oh yes, absolutely.
Well, yes.
Yeah. So Mars sample return, its current launch date is TBA, and then MMX is in the next window in 2026 with that there. So it should arrive by 2027. Hopefully have those samples back by about 2030 around there.
Yeah.
With that, but I also feel like that's important because we're having samples come back from Mars, or at least the vicinity of Mars. So we can kind of get a little experience, and then if JAXA wants to help out with that, we'll take all the help we can get. Send your money now, everybody, to help make Mars sample return happen. The European Space Agency also has their Rosalind Franklin rover, which is going to be launching in 2028. It was originally supposed to launch in 2020, and then there was a little bit of a delay where they said, okay, we're going to have to do it in 2024. And then the supplier for the lander, this country you may have heard of called Russia, did some things that were geopolitically not so great, and they were basically like, we're not providing your lander anymore, so they had to go back and redesign it with it there. But they're moving along steadily with that there, and I'm very glad they named it after Rosalind Franklin, great scientist. We could just, Watson and Crick, throw them out. Then we have this right here, which is NASA's Psyche mission, which is going to be an orbiter. It's going to do an orbiter flyby of Mars on its way to the most metal asteroid that we know of, Psyche, in a multitude of ways. So I'm excited about that. That one's going to be coming up actually very shortly. We also have ESA's Hera mission, which is actually going to be going back to the Dimorphos-Didymos system that I'm so excited to see.
I'm really excited about this.
Yeah, to see the results of DART, the Double Asteroid Redirection Test mission.
That's when we slammed into the little asteroid with the thing to see if we could move it.
Yep.
And we did. It was moved. It moved much further than we thought it would.
That one was for the dinosaurs, baby. We did it for them.
Yeah.
And it was orders of magnitude better than we expected it to be. So that means that we could actually go out and punch an asteroid and it will work very well.
If one were coming on a collision course with Earth, we've learned a little bit how to deflect it, and this is important work. As much as we love to joke about it, this was very, very important work.
Great mission. And this will be a orbiter flyby for a gravity assist at Mars as well. And just kind of talking about the robotic missions that we've had to Mars. You can see the Soviet Union did a lot early on, and the United States came in, and we've kind of been dominating that. We've also got Japan getting in the mix, China as well. India has come in, the United Arab Emirates as well.
Some of these are orbiters, some are landers. The ones that end in space are orbiters. Ones that go all the way to the ground, of course, are landers or rovers. Now, the ones that terminate with a little red dot are failures.
There was a lot.
So you can see how hard it is to get to Mars. It is not easy. So it is remarkable what our local JPL has been able to do, the Jet Propulsion Laboratory over in Pasadena, They have amazing success, and it's because they pass along their knowledge. Well, they learn things from one mission to the next. We mentioned Curiosity's wheels being destroyed by driving over sharp rocks. They had to be very careful. The mission could have come to an end if it had kept up. Well, they learned what to do, so Perseverance's wheels are holding up really, really well. So they pass along the knowledge and learn from their mistakes. So that's one of the reasons we're so successful, the United States.
Yeah, and also developing knowledge, a actual new knowledge base as well, which is something that we did with this vehicle.
Yeah.
It is bitter.
You're starting the movie on me, Jared.
Sorry, all right.
That's all right.
Feel free to go ahead.
Yeah. So anyway, so we wanted to celebrate the end of the Ingenuity mission. That was a little helicopter that got sent to Mars. So we made this little video. Bill put it together mostly. Thank you so much for this, Bill.
Great editing by Dr. Reitzel.
Well,
Seriously.
a combined job, but you did a wonderful job. So let's take a look at it.
It is bittersweet that I must announce that Ingenuity, the little helicopter that could, well, it has now taken its last flight on Mars. And so, thank you, Ingenuity.
I'm incredibly proud and grateful for all that Ingenuity has been able to give us.
What would you say to Ingenuity during last time?
You're gonna make me cry, you know.
What would I say to Ingenuity?
It's really hard to say goodbye to you.
I would say thank you.
Ingenuity, thank you for bringing us all together.
Thank you for leading the charge in our adventure on Mars, and we will never forget you.
Rest well.
Thank you, Ingenuity.
Thank you, Ingenuity.
Thanks, Ingenuity.
Thanks, Ingenuity.
This is how it all started. It wasn't, that's gonna fly on Mars. All right, this is a little better. It's hovering, it's still tethered in the sun Earth. They had to get it to Mars. So it rode with Perseverance on its belly. This is how it deployed. Sped up a little bit. So an animation would be dropped off and off would drive Perseverance.
This is downlink. We are beginning to see data products. Altimeter data confirms that Ingenuity has performed its first flight of a powered aircraft to another planet.
And the footage of it flying is captured by Perseverance. How cool is that, to have a camera robot to capture your helicopter flying?
From that moment forward, really, we were off to the races and saying, okay, great, that's done, let's get back to work. Let's get to flight 2, and then 3, and then so on and so on. How fast can we fly? How high up above the surface can we fly? We started doing things in parallel with the rover, and we've also demonstrated that the helicopter can be a scout to help scientists.
NASA and
Thank you,
JPL
NASA,
for that. It's
Amazing.
an amazing mission. The Ingenuity helicopter, 5 flights planned, and it did 72. It had 79 feet. It was its highest altitude it achieved. That's pretty high. It was the first helicopter on another planet. 128 plus minutes of flight, over 2 years of lifespan. It flew 11 miles. This was like just a little a test helicopter. So incredibly successful. A mission has been green-lighted, the Dragonfly mission, to go fly a quadcopter on Titan. That hopefully will happen. That's a moon of Saturn that has liquid methane and ethane, seas of ethane and methane. Imagining flying a quadcopter over those and getting views. So this has proven the science is at a whole new level, and we have a lot to look forward to. And it's been fun having it explore Mars, so amazing stuff. Well, thank you everybody for joining us tonight at All Space Considered. Really appreciate you. Thank you, panel. Appreciate what you've done. Thank you, crew, everybody out there, camera folks, the group in the booth. And as always, we want to thank our exclusive nonprofit partner, Griffith Observatory Foundation, that has made this theater so wonderful with these upgrades. Thank you, all the folks that made that possible. And also, this city's brought to you by Griffith Observatory, the Department of Recreation and Parks, and of course, the City of Los Angeles. So thank you all, and we'll see you next month.
Thank you.